All right. So let's get started. 3, 2, 1. Hello, and what is up, everybody? Welcome to the Data on Kubernetes Community live stream number 121. Thanks for waiting, hanging on just a little bit. To build the suspense, we've got a solid audience, got a lot of people that signed up for today's live stream. Before we get started, just housekeeping reminders. The clock is ticking, folks. Today is March 10th. And on March 16th, the CFP for our co-located event in KubeCon will be closed. I'm also inviting today's speaker to submit his talk as a CFP, as it very much ties in with what we're looking for. I'll drop the link here in the chat so you can check that out. Very clear instructions in terms of the kind of topics that we would like to see presented in terms of guidelines. Today's talk would be no exception in terms of what we're looking for there. That being said, I would like to introduce, this live stream has been a long time coming. I think the first time we talked on LinkedIn was well over half a year ago.
Yeah.
But glad that we're finally making this happen. Steve Buchanan is a principal program director at Microsoft, but he is a lot more than that in his background. So I want to turn it over to him. Steve, welcome.
Thank you. Thanks, Bart. I'm going to start the presentation here just so folks can see that, and then we'll go through. I'll do a little introduction of myself, and then we'll dive into the topic here.
Fantastic. So, as usual, sorry to interrupt you. Just so folks know, keep your questions going in the chat. We'll get to them accordingly. And if we need be, we can continue the conversation on Slack after the live stream. Anyway, take it away, Steve. All you.
Awesome. Thanks, Bart. So today we're going to talk about running stateful apps in Kubernetes. I'm sure that's why you're all here. But before we get started with that, I just want to take a moment and recognize, the war that's going on, the tragedy, the horrible things that are happening in the Ukraine. And if you can, and donate to the needs for the people that are being impacted by that war. There's a link there. I'm sure there's many other links and organizations out there. There's horrible things that are going on right now, and I just want to recognize that. And all of us are fortunate that we're still able to do what we're able to do. So let's help those that are in need right now. So with that being said, just going into a quick intro about myself. So I'm actually located in the US. I'm in Minnesota, so I'm up north. I'm from here. I'm actually a principal program manager with Microsoft. Recently joined. Before that, I was in the consulting world with Avanade and Accenture. Been in IT for 22 years, and I was an MVP for 10 years before I joined Microsoft. I'm an author of 8 books, so I have some books out there on Kubernetes. So definitely pick those up. And also I have some courses out there on Pluralsight for Kubernetes as well. So just a quick plug on those 2 things and some links so you can find my stuff. There's a GitOps course, there's other courses on Kubernetes, and then I have several books, right, with O'Reilly and Apress and etc. So here's what we're going to talk about in this session today, specifically around stateless apps in Kubernetes. So we're going to talk about what stateless apps are. Then we'll dive into the storage of Kubernetes. It's important to understand that before you get into stateless apps or stateful applications in Kubernetes. And then we'll talk a little bit about stateful sets. I'm a Microsoft guy, so I have to go into the Azure world, and I'm going to talk about what options are there in Azure for Kubernetes, specifically Azure Kubernetes Service. We'll get into some best practices, and then we'll finish it off with a demo. And we're going to use a little GitOps there to deploy some stateful apps. So stateless versus stateful. So stateless apps basically don't require any data to be saved, right? So usually those are things like front ends, maybe an API that you're running. Front end for web apps are pretty common. I've also run, like Fire servers, which is a medical application as a stateless app. And then there's usually like a database on the back end somewhere, right, outside of Kubernetes. So stateless, there's no user state, there's nothing that needs to be saved. So if pods restart or anything like that, it's not a big deal. They get moved around to different nodes. Now, Stateful application is, there is user state, there's state of data, there's basically data or configuration of some kind that has to stay there, and you don't want that to disappear, otherwise it's very, very bad, right? So we can think of a very common application, WordPress, for example, right? There's a front end and there's a database to that, and there's configuration you don't want to lose if, let's say, the containers are turned off, right? The pods are restarted or what have you, or the node cluster goes down. And so typically we don't run stateful apps in Kubernetes clusters, but you can. And I came from that consulting world really very recently, and most companies are still not running stateful applications in Kubernetes, but there's a huge interest in doing it, and companies are starting to experiment with that and starting to explore the options there. And also cloud providers have started to enhance their cloud offerings around Kubernetes to make the experience with stateful applications better.
And Steve, what do you think are some of the reasons as to why companies have waited up until now? What's caused the doubt or, lack of certainty there regarding that?
It's just Kubernetes was not originally designed for stateful applications. I think that's one reason. And so, the idea of the orchestration, pods being stateless, so it's easier to move them around. And then just fear, right? We saw the same thing with virtual machines of like, don't run SQL Server or any database on your VMs, right? We saw that for a long time. And then that started to change. I think we're going through that same thing in the Kubernetes space, where companies are starting to get more comfortable with it as they're increasing their skills and their teams around Kubernetes talent, right? And understanding how to operate Kubernetes clusters. Also, cloud providers, right? I worked for Microsoft, and there's a lot of work going into making the experience of running stateful applications just more optimized, better, and enhancing that. And I'm seeing that across the cloud providers, the major cloud providers. So I think we're going to see more and more adoption of stateful applications. The interest has been there, and we're going to see that fear kind of go away as more and more people are doing it and talking about it.
Perfect.
Now, just to give a visual of stateless versus stateful here. So again, with the stateless, we typically see things like web front ends, APIs, CDNs, things like that, maybe a print application or some other miscellaneous application. And then on the stateful side, right, more complex applications, web, running a database as containers, things like that. Now, here's an example of some applications on both. So on the stateless, things like Node.js, Nginx, Tomcat, Apache, you can see a theme there. Web applications, web servers. On the stateful side, WordPress. Now, traditionally, we'll see WordPress like the front end running as containers on Kubernetes, and then we'll see database outside of the cluster, right? Same thing with like Drupal. But then we have applications like Jenkins where the configuration is stored in flat files, right? Stored as XML, and is coupled with the application. And so that would be stateful. And then of course you have things like MongoDB, etc. Right? And so here's what it looks like from an architecture standpoint. So for the stateless, and we'll see if my my clicker works here. So on the stateless side, you'll have a service here, right? That's running your pod, or could be multiple pods. And inside the Kubernetes cluster, that's where we are right there. You won't have any database. You won't have any storage there. That stays. You'll have storage that that goes away when you restart the pods, right? And then you'll have your database living outside of that Kubernetes cluster. So that might be cloud, that might be running on a VM, whatever. And then on the stateful side, you have your pods here that are running your service or services. You might have you might have a persistent volume claim, and we'll talk about what that is on that pod. And then you might be running your database as a pod as well with that stateless application, and you might have those persistent volume claims there as well. And so everything in this stateful application architecture is running on the Kubernetes cluster. So that's just illustrating kind of that difference. Now let's get into storage on Kubernetes. So you have volumes, and volumes are basically your underlying storage, right? So it basically represents your underlying storage. So this could be things like, NFS, iSCSI, or if it's a cloud provider, could be Azure Disk, or if it's on AWS, it could be, what is it, S3, right? And so volumes can be file-based or block-based. And so if they're file-based, that usually is because you want multiple pods to access that data, right? So think of that as file shares on a file server. And if it's block-based, think of that as attaching like hard drives to pods, right? So those pods can access that data, right? So you usually go with one or the other as far as volumes. What else on this slide? So I didn't want to just drain the slide here, but essentially those are volumes. And then we have storage classes in Kubernetes, and the storage classes are a way for Kubernetes administrators to basically define your tiers of storage, right? So for example, you could have premium, you could have standard, you could have other tiers that you want to make available when someone's adding a persistent volume claim to their pod. And we'll get into that a little bit more. And so this is where your Kubernetes admins can go in and add whatever storage classes they want to be available. Now, on the cloud providers, they have storage classes added by default as well. And we'll go into that around Azure and what's there. Now, with the storage classes, these define certain things, and what they define are the provisioner, parameters, reclaim policy, and the reclaim policy is important. And those are things that apply when you go ahead and set up the persistent volume, right? And we'll talk about that, and it impacts the PVC as well. And so typically with a pod in Kubernetes, when you delete the pod, the storage that is there goes away unless you have persistent storage, unless you have a persistent volume. And so the storage classes will help you with that. They're there for those persistent volumes to help with those stateful applications. Now, the reclaim policy basically controls the behavior of the underlying storage resource after a pod is deleted, right? So if you delete a pod, the reclaim policy is going to define what actually happens with that underlying storage after that process. And so this is really important. So you have three types of reclaim policies. You have the retain. And so if your pod is deleted, like you remove it, you might want to make sure that the data is still there, right? And you want to make sure that someone has to go manually remove that storage before it goes away. And so that's what that retain will do. It'll leave it there, the underlying storage, and an administrator has to go and do something with it, right? Remove it, or maybe attach it to new pod, that sort of thing. And then delete we'll basically just delete the underlying storage if the pod is removed, right? And take note, I'm saying removed and not restarted, right? And then recycle will basically scrub the underlying storage and just make it available again for a new claim. Now, in the context of Kubernetes, right, we configure everything through YAML files. So here's some code just to give you an example of what a storage class looks like and how you define that. So pretty straightforward if you're used to working with Kubernetes manifest files. Couple of things I'll point out there is you have this provisioner, right? So that's like, what's going to provision this, right? So in this example, Azure Disk. And then there's your reclaim policy. So how are you going to handle that? And then any parameters that you want to have. Now, these might change across different cloud providers, or if you rolled your own Kubernetes and you're just using your own storage, those things are going to be different. Now, let's talk about persistent volumes. So you have volumes and then you have your persistent volume. So you need to create a persistent volume. And that's basically carving out some storage and making it ready so that when a pod is spun up on the system with a persistent volume claim, and we're going to talk about those next, it will allocate, whatever you have in your claim. Let's say it's 10 gigs, it's going to allocate that from the available persistent volumes, right, for your pods. And so there's two ways to provision, or there's two ways that persistent volumes work, right? Manually or dynamically. And we're going to show you what it looks like when they're dynamically provisioned using those storage classes, right? And again, the underlying can be NFS, something like iSCSI, or even cloud-based storage. And here's an example of code for the persistent volume. Again, it's just YAML. It's pretty straightforward. A few things we'll highlight here. So under spec, you can specify the storage amount, like the capacity. Is it file system? Is it block? Your access modes. These are important, and we'll talk about that. I have a list of what these are. And then here's a reclaim policy here, class name. You have different mount options, and that's going to change depending on type of storage and what you're doing. So your persistent volume claims, basically this is a request for storage, right? So you add code in your YAML file to your pod to request storage. And so when your pod is deployed, it's going to make that request, and it's going to look for any PVs that are available that have capacity, and we'll go ahead and provision that storage for your pod. And so you want to have your PVCs typically coupled with your pods, so be a part of your configuration files in your pods. And then the PVCs determine the volume mode. So whether it's going to be block or file storage, it's going to determine your access mode and your capacity, right? And then your access modes there are listed there. So you have read only many. And so that's going to mount that storage in read only mode. So you'll be able to access the data, but not write back to it. And then read write once is another access mode. And so what that's going to do is it's going to mount it by a single node, and you'll be able to read and write. And you'll be able to do that from a pod. And then read write many, you typically use that with file, and allows multiple nodes and multiple pods to read and write to it. So again, think of that in the context of like file shares if you have multiple pods that need to access that storage, that sort of thing. And then here's some code for, here's an example of code for a PVC. And so again, pretty straightforward. You have your storage class name, right? So that's the storage class is going to use. You have your access mode that you're using there. And in the demo, I'm going to show you, I could show you another PVC that has a little bit more to it. Now, what's the life cycle of volumes and claims, right? So provision, so that's happening either statically or dynamically. And we'll show that in the demo. And then there's a binding that happens. And so PVC, a new PVC comes into the system, into Kubernetes, and it's looking for available PV that that matches, right, with the available amount of capacity, the right storage class, and then it will go ahead and match them, right? And then that volume is going to be mounted to the pod or pods, depending on if it's file or block. And then it's going to be basically put in use. So it'll be bound up so that no other pods can like use that. And it's not going to be removed. Like, let's say if a pod is moved to another node through orchestration, it's not going to, you don't have to worry about your storage going away. And then when you delete a pod, when you're done using it, what happens with it? That's where the reclaim policy comes in. And that's where that reclaim part of the life cycle comes in. So it's going to retain that underlying storage, right? That data on that storage is going to delete it, make it available for the next claim that comes along, or what is Kubernetes going to do with it, right? Now that was Kubernetes storage. Let's get into stateful sets. So stateful sets are basically Kubernetes objects, and they're used when you have pods that need their own independent state and they need their own independent volume. So with stateful sets, each of your pods are assigned a unique name, and you also can have a unique network ID as well. And it stays with that pod, even if you delete it and you like recreate it, it's going to have that name. Also, you would use this if you have an application where you have certain pods that need to come up in a certain order, like pod A needs to be deployed before pod B, before pod C, that sort of thing. And if you're doing upgrades to an application, and maybe an upgrade needs to happen in a specific order as well, and or you have network traffic that needs to hit certain pods and always hit certain pods, like this is a way to have unique names for your pods versus just a random string attached to the pod name like it typically is, right? And then you will have typically a headless service deployed with your stateful sets, and that's not going to have an assigned IP. And so you have to configure the ingress into that headless service, if that makes sense, right? Versus like if you deploy a load balancer or an ingress, it's going to assign an IP. So you're going to have a way to hit that, or it's going to assign an ingress, provision an IP for that. So you have a way to hit that service behind, to hit the actual pods behind, that service. With a headless service, you don't have any of that. So you have to configure that on your own. So they're a little bit more complex. So here are some use cases when you're running, some use cases for running stateful sets. So again, if you need that unique network identifier, or you need the unique name identifier for your pods, you'll want to use that. You'll want to use a stateful set. if you need to have persistent storage for each pod, and those pods need to be unique, right? You can use that with stateful sets. If you want to have the ordering when you're deploying, when you're scaling, as well as when you're updating the application, then you'll want to use stateful sets. Now, stateful sets would be used as opposed to like deployments in Kubernetes, right? So let's talk about some storage options for AKS, right? So data volumes in Kubernetes can be based on Azure storage, so they'll be based on that cloud storage, and we can manually create volumes for assigning to pods, or we can have Kubernetes just do it dynamically, right? Create them. And then with this, you can use Azure Disk, or you can use Azure Files as the underlying storage. And with Azure Disks, they're mounted as read-write once, and they're only available to single pods. So that would be your block storage, right? And with Azure Files, it's basically backed by a storage account, and you're using the Azure File Service. And this would be used if you need to share data across multiple nodes and multiple pods, right? For example. And then in Azure, you have premium storage, you have standard storage. So the premium is going to be SSD, and then the standard is going to be just standard HDD spinning disk. And so keep that in mind when you're going to plan out your performance needs and your production and your development workloads. There's going to be different cost points there based on the different type of storage, right? And by default in Azure for AKS, there are some storage classes that are automatically there. Again, you can create your own storage classes, and we'll show you that in the demo, but there's some storage classes that are already there, and you could simply use those. And that's what's listed here on the slide. And so take note of the reclaim policy. That's what's there by default. So again, if you need to have retain or a different reclaim policy, right, you'd be creating your own storage class. Now, when you create your own storage class and you go to deploy a pod and you have a PVC in there, things are going to happen automatically for you. But you would have to have that storage class in there. And just to give you a visual of what this looks like, so we'll see if we can highlight this. So you would have your AKS cluster, you would have your persistent volume, and then outside of that, you would have, either your Azure managed disk for your block, your Azure files for, for multiple access, right? And that would live in the Azure services outside of that AKS cluster. Now, here's an example of a PVC, and we'll highlight this. So here's your AKS cluster. You have your node over here running with your pod on it. You have a PVC from your pod, and that's working with a storage class, whether you're using one of the default or you created your own. And then there's a persistent volume, and that persistent volume is using one of the underlying cloud-based storage options, right? So let's talk about some best practices, and then let's get into the demo, and we'll show you what this looks like. And so you want to avoid manually creating and assigning the persistent volumes if you can, right? The ideal way to do it is to let it dynamically provision. That's going to reduce potential for, human error, right? And then in your storage classes, you want to make sure that you're planning and using the appropriate reclaim policy, that's going to force you to kind of look at that and make sure you're using the right reclaim policy, minimizing storage costs. You want to make sure you understand the reclaim policies and you're using the one that fits your needs. And then if you, like, let's say if you use retain on all of the storage classes that you're going to use, and you have folks deploying stuff and deleting stuff out of your environment and everything is retained, and you have storage just sitting there, no one's actually using it, right? You're paying for that. So you want to pay attention to that, your reclaim policy. And then the Kubernetes documentation recommends the following for PVs and PVCs. So this is really good stuff to follow. You want to include your PVCs in the pod configuration. So in your Kubernetes manifest files, you want to couple those PVCs with your pods. And I mentioned that earlier, right? But you don't want to put your PVs in your Kubernetes manifest files for your pods, right? You typically want to have those separately and have those provisioned. That way you don't have pods that are tightly coupled with specific volumes, right? Because pods are going to use whatever volumes available. But PVCs are tied to pods specifically. And then you'll want to have a default storage class, right? So with cloud providers like in Azure, there is a default one set. Just make sure you know what that is and make sure you're using the one that fits your needs, right? If you didn't have any set, then your PVCs would fail when you go to deploy your pods, and it's just one more error that you have to deal with, right? But in clouds, it's not going to fail. Just make sure you're understanding what storage class is set to default. Make sure it fits your needs. And then this one's a pretty obvious one, but it's always good to state, like, use meaningful names with your storage classes. This expands across all of it though. Use meaningful names with your PVs as well. Just use meaningful names across the board. And then for production workloads, use SSD premium storage. Again, different for every environment, but recommendation there. And then there's two more. So plan appropriately when you're planning out your storage, when you're planning out your stateful applications, when you're planning out what you're going to do, like what storage classes you're going to use, reclaim policies, how things are going to work in your environment, what your needs are, your nodes, right? You need to make sure you have the right sizing on your nodes. For example, if you have underlying nodes that don't support premium storage, but then you go and you put premium storage in your PVCs and you go to deploy, you're going to get errors, right? And things are going to fail. So you need to kind of pay attention to that stuff up front and plan accordingly. And then persistent storage does not equal backup. So the data is there. You want to make sure that you're backing up that storage, right? You're backing up your data for your applications. You'll want to use a tool like Farrell, right, for Kubernetes backup, or some of the cloud providers can back up the storage. And so just make sure you're paying attention to that and planning accordingly there. So now let's dive into a demo and we'll see if everything works right on the demo. So let me flip over to my browser here. All right. Let's refresh this. This may make me log in again. Nope, we're good there. So what we're going to do is I'm just going to deploy a couple of stateful applications. So to AKS, Azure Kubernetes Service, to manage Kubernetes service in Azure. And so I'm going to go to one of my AKS clusters here, and we will just go to namespaces. We'll open the Cloud Shell here. And so what I have here is out on my GitHub, I have a couple of repositories. Let's just open these up. I have Jenkins and I have WordPress. And so what we're going to do, we'll deploy the WordPress first. And so we're going to use GitOps to deploy this. But what I want to do is show you like how it provisions all of the storage that's needed, right? And then we'll go through some of the YAML that's in my repositories to show you what that looks like. And we're going to do this via GitOps. So GitOps basically points to a Git repository, and then it's able to deploy and provision from there. That's a whole nother conversation that we could get into. But I thought it'd be kind of cool to show deploying from GitOps. So we're using Argo CD here, and this is a GitOps operator. And the GitOps operator will, you can create an application in here in Argo CD. You point it to your Git repository. It's going to look at your Kubernetes manifest files, and then it's going to deploy that stuff on your Kubernetes cluster. And it does that all for you. So it's really efficient.
Really quick question, Steve.
Yeah.
So someone from the audience, Craig, asked, so if you delete or recreate the PVC tied to a retained storage class, when deleting or recreating a pod, the data in the volume will persist and be reassociated when mounting the volume again, correct?
Repeat that question. That was a long one.
No worries. I'll put it in the chat here too. Okay. So if you delete or recreate the PVC in parentheses tied to a retained storage class, when deleting, recreating a pod, the data in the volume will persist and be reassociated when mounting the volume again, correct?
If you have that if you have the reclaim policy of retain, yes. Yep. So when you delete that pod, that data is still going to be there. And I'll show you in the portal. Actually, I'll show you right now. Let me create this application.
Okay.
Let me make everything right. And now I'll actually show in the portal because I have some storage. I have some PVs that are still sitting there, right, with data on them, right? And the pods are long gone. So we got our app name. Just want to make sure we have everything right. That way it this works right. So all right. I think it's all right. So we'll see what happens here. So this is going through and it's creating everything. And as long as I didn't make a mistake in the configuration, then it's going to deploy all the stuff that's needed there. So you can see right here that we have a persistent volume claim right here for our MySQL. We also have a persistent volume claim for our WordPress, right? And so we have a bunch of other things in here too, like we have some secrets and services and our deployments and ingress here. This is our underlying storage that our pods are going to use. And so this is all, that's all working. So we're good to go there. So if we come in here, first of all, doing it through GitOps, it created the namespace for us. So there it is. And I know a lot of people would go through the command line and use that, which highly recommend. I just want to show you in the portal because it works really well for demos, right? As we're navigating through the Kubernetes cluster. So if we come in here, I can drop this down. I can go to the namespace that was just created, and I can see there's my MySQL, there's my WordPress, and then I can do the same thing over here on the pods just to see the underlying pods. One thing about stateful sets, right? So if we were deploying this as a stateful set, you would see that stateful set there. You wouldn't see that. You wouldn't see this workload under deployments, right? And you'd have a headless service and there'd be more configuration you have to go through. But so here are the pods. And I believe if I click on one of these pods, I can do either one. I could actually go here and see the volume that it's using, right? If I come back over here and I go to storage, I can see my PVCs. You can see the two that were just created with, that deployment from GitOps. You can see the volumes that are associated with them. You can see the capacity. You could see the storage class that's being used. You can see it was just deployed. You can see this read write once for the access mode. And you can see here, this was a Jenkins workload that I was working on. And this is actually a read write many, and it's using a different storage class. And that was a storage class that I added to this Kubernetes cluster. You could see that the WordPress that I just deployed is using default. Now we're going to deploy another Jenkins, and that has a storage class YAML file in it. So it's going to add the storage class that we need and go ahead and deploy it from GitOps. But if we go into persistent volumes here, we can see all the persistent volumes that exist, right? And to go back to that question, Bart, that just came up, you could see some old PVs here that are in a released state, but they're still hanging around. These are not actually attached to any workload that I have in my Kubernetes cluster anymore. Like the pods are gone, the deployment, all of it. I deleted all of it, right? The namespace that it was under, that's all gone. But the storage is still here. So I could go and redeploy and attach these PVs to it, and my data's there, right? And the underlying like Azure storage is still there, it still exists. So the data is still there. Like Kubernetes is holding on to that. And that's because I have a reclaim policy of retain, right? But you can see the reclaim policy on these other ones. So here's our WordPress that I just deployed. If I deleted the deployment for the WordPress, right? If I ran a kube control space delete, or delete deployment, blah, 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 it's going to kill this storage as well. It's going to delete that. So my data would be gone. Now, if the pods just restart or move around to, they're moved, this is still going to be here. So your storage is still going to persist. Now, here are the storage classes, and you can see a number of them that are in here that are default. And then here's the one that I added, right? So this is one that I added. You can see it hasn't been in there that long. The other ones are the same age as the Kubernetes cluster itself. This one is the age, I just deployed that in there not that long ago. So let's do this. I'm going to deploy Jenkins as well. So let's go back to our GitOps. And Bart, hopefully that answered the question. I can't actually see the chat, so I can't see it.
Seems to be good, but Craig, if you have any follow-up on that, just let us know in the chat.
Cool. All right, so again, we're going through our GitOps, and we're going to just deploy the Jenkins here. And so I'm checking some things so that like when I delete the applications at the end of this, it's going to go ahead and clean up the resources of my Kubernetes cluster. So I don't have things just hanging around there. That's what this prune resources is for. So I do that there. And then the repository URL, and the YAML file. We're just deploying to our same Kubernetes cluster. We'll do a copy and paste here. And then I think I have everything right. So I think we should be good. We'll find out shortly here. So again, we're using GitOps. So it's just like, I'm just pointing it to my repository and told it go, and it's deploying all the things. We'll see a new namespace pop in here in my cluster for that Jenkins, and there it is. It's already deploying that. Now let's go into the repository. We'll just do a little exploring in here. So we're going to the YAML folder. So notice I have a couple of YAML files for storage classes, and I think I'm using this one. So we'll open that. So pretty straightforward here. So I'm giving it a name. And so if I go in the Kubernetes cluster, we will be able to see that name there, right? And I'm attempting to use useful, meaningful names. Provisioner is Azure Disk. If you're on another cloud provider, this is going to look different. If you're you rolled your own cluster and you're using your own storage, not cloud-based, this is going to look different. There's documentation out there in the official Kubernetes documentation that'll go through that stuff, or that cloud provider. Like there's a bunch of documentation out on the Microsoft Docs site that'll go through all this here. So if you want to know what settings can I tweak, what should I have, what's available to me, you go reference the documentation. And then I'm using a retain policy or retain reclaim policy because the defaults are set to delete. I want my data to stay even if I delete my pod. And then I'm telling it the type of storage here. And so pretty straightforward. So if we go over here and we go into storage, and let's go into storage classes. So you could see this was just added, and this was just added 2 minutes ago. Now, the other thing you'll notice is in this folder, and typically you wouldn't want to do this in a production environment. We're just doing a demo here, but I also have premium. And typically you wouldn't put it in a folder like this with your application and then have GitOps deploy all of it. You deploy your storage classes ahead of time. You should have planned that out, like what type of storage classes should I have? What are the reclaim policies? And you would deploy those things ahead of time, right? You wouldn't have the YAML for those sitting in the same folder with your actual application deployment. But this is a demo, and so I just wanted to illustrate all of that. So you'll notice for the manage premium retain, that's 2 minutes old because it added that too. So if we go into this, we could just see, information about it. Like the reclaim policy, does it allow expansion? So being able to expand the capacity on our PVs after they're deployed, things like that. So let's go up here. Let's go to persistent volumes. So we should be able to see there's our Jenkins, is that? Let's go over here and we should be able to tell. So I'm going to scope down the namespace. So this is the Jenkins PVC for the Jenkins workload that we just provisioned. And you can see there's the PVC volume, or the PV that it's referencing. So A519, and you can see the capacity and the storage class that it used. So if we go into here, there's A519. So this is the one that it's bound to. This is the one that it's using. Now, what else do I want to show you? So if I go back in here, I want to show you this. So if I click here, I want to show you that, okay, this is file-based PVC. And so this is based on Azure files, and you can see that there are 3 pods. So there's 3 replicas with that deployment, and these pods are all accessing that storage, right? So you can see that there. Now, if we go back here, and let's just go into this other one. And which one is that? Might be the wrong one. No. Oh, I did 3 on that one as well. Let's go into the WordPress. And you can see that there's 1 pod there accessing that. So the last thing I want to show you, let's go into the YAML for the actual workload here. So here's our persistent volume claim, and we give it a name so we know what it is, and we can reference it right from the actual pod itself. There's our access mode. There's our storage class. And so we can change that. There's our capacity that we want. And so if we were deploying and this wasn't available, we would get an error, right? And if we come down here, this is our actual deployment, and we go down a little bit further. Here's our container. It's pulling the Jenkins image, and then we have a volume mount here, and we're referencing a volume, and the volume is right here, right? That's the name of it. And then this volume is referencing the claim, the PVC from above, right? And then if we go back to the PVC, there's the name of that. So I think that wraps up the demo there, and that brings us to the end of the session.
Very, very good. Solid. I was just telling somebody particularly the first slides in the beginning of just really clearly laying out differences between stateful and stateless is something that we've had in conversation, but we've never had a speaker that's really put it down the way that you did. So I'm very grateful to you for doing that. It's extremely helpful as a resource. In your whole experience of starting to work with data on Kubernetes, because this talk was focused on making things simple, what have been some of the challenging aspects for you?
Challenging aspects as far as like the storage, or in what context?
Yeah, storage specifically.
Yeah, so challenging aspects are always like, what type of performance do I need, right, for this application, especially if it's greenfield and maybe you never worked with that application before. Like, how do you determine that? Now, if you're migrating from on-prem to Azure, and let's say you're going to modernize with that, you might have some history with that application, right, running on VMs. So you probably know, okay, I need this type of storage. I need this capacity. This is the estimates of how large it's going to grow over X amount of time. So you can put some better, you can pinpoint what you need better versus greenfield. And it's really important to kind of get that down up front, and know what you're going to need. Also, making sure that you have the right size of nodes to fit the need for the storage that you're gonna run on there, right? Versus you just deploy Kubernetes, you don't really pay attention to the size of nodes, you just kind of pick some large ones or whatever, right? You didn't really plan ahead, and so now you have a Kubernetes cluster, or you have some Kubernetes clusters, and now you've decided, oh, we're not just going to run stateless, we're going to run some stateful applications on it now. Well, if your cluster's been around for a while, does it meet the needs of these stateful applications, right? Can you even, are your nodes even going to support the type of volumes that you want to run on there, right? In my environment, that's just a demo environment. It's just a personal Azure subscription that I have. So I don't deploy the biggest and most expensive things, right? And so on that cluster, I can't even deploy premium storage because I went with the least amount of resources on those nodes because it's just a demo environment, right? So there's no way I'm going to run production. But so if I went to deploy a stateful application using premium storage, is going to fail on me. And then what? Now I got to figure out, okay, do I add another node pool with some new nodes that are going to fit the specs that I need so I can run this premium storage? Do I deploy a new cluster? Like, what do I do, right? And so I think that's something that folks should pay attention to up front too. Got it.
Yep. Couple other questions from the audience before we wrap it up. Someone asked, how is CSI involved in all this?
Yeah, that's a great question. So I didn't go into that. That's a whole nother discussion.
Part two.
That's part two. But the gist is that basically, right, there's CSI, there's also config maps. And so like with CSI, you can store secrets on there. And then like with config maps, right, you can store data on those you can store within config maps, you can reference data and store data on persistent volumes. That way, when you're deploying your pods, your workloads, if you need to have configurations happen, right? And so by default, Azure has some storage classes out there for like CSI to fit that need, but we're not going to go down that path right now.
No, for reasons of time, but yep. Thanks for touching on that.
That's a great question though.
Yeah. And then we have a couple of follow-up questions from Craig, who asked a question earlier about retained storage class. So he asked, do we need to manually set node affinity when using read-write once PVCs?
That is a good question. I don't know. I'd have to go dig into that. I'll do that and then tweet that out.
Okay. And then, and then a follow-up to that, but I imagine related. Do we need to not use read-write once when running multiple replicas of a pod so they can be on different nodes?
I'll have to dig into that one too.
No, good, that's fine. This is the whole point of these sessions often is not just about having answers, but getting new questions. So I think that's good.
And I love that too. You know, those are things that we need to think about as we're thinking about stateful applications on Kubernetes. And the other thing too is, right, I said in the beginning, I came from the consulting world. And so we're seeing the uptick in companies interested in running stateful workloads on Kubernetes, but we're not seeing a ton of it. At least I didn't. But as more and more companies are doing this, we're going to see more and more best practices and kind of standards in the communities around, hey, what do I do in this scenario? What's the best practice for this, right? That sort of thing.
Agreed. And that's one of the primary reasons why our community exists, is so that people have a reference point where they can get that knowledge and hear from different practitioners about how they've met the challenge. Speaking of that, though, if you had to choose what for you, what is the primary advantage or reason why you would tell an organization, I think you should be running stateful workloads on Kubernetes? What for you is the main benefit?
It's centralizing the entire workload on one system, right? Versus I'm going to run my front end here, and then I'm going to run the database over in this managed service or maybe on a server. I have an example. This was on a former project. We had part of the workload, right, for this application running on Kubernetes. And then we had a database, right? And it was a RangoDB, and there wasn't a PaaS service available for that database, right? It's an open source database. And so we had no choice. We had to run it on VMs. And in today's day and age, I try to stay away from VMs if I can. I prefer, PaaS kind of as a first place to land things, and then if I can't land them there, as containers, just because of the portability and the orchestration and all the benefits that come with that. But in that scenario, we had no choice. We had to run it on a VM. So now, right, we introduced service mesh, and now we had to get service mesh working between Kubernetes and this open source database running on a VM. And in its Linux operating system, so it just added like additional layers of complexity. Yep. And so it would have been nice, and we probably could have explored this, but it would have been nice to just run it all in Kubernetes.
Very good. And this has come up on previous occasions of one stack to rule them all, as you mentioned, for reasons of simplicity, have everything all in the same place and not be having to bounce around. Right. Good. That's great, Steve. We are at the hour. It's quite obvious that you're a published author and that you're a Pluralsight. You're teaching classes on Pluralsight because the way you explain things, it's a complex subject, but putting things the way you've done, like I said, I'm very, very grateful. This live stream is going to get a lot of mileage for a lot of folks that, like I said, know that this is coming, but aren't exactly sure where they should start. It's a bit overwhelming for some people out there. But I really appreciate for how well you put everything. I do need to share my screen really quickly before we finish, so don't worry, you don't have to do anything. While you are talking, we have an amazing artist who is creating a graphic depiction of the things that were covered in the talk. So here we can see some of the different things that you spoke about throughout the course of the live stream. You left your links on there. You're pretty easy to find on Twitter, LinkedIn, etc. That's how we got connected. It was great to have you with us. I really hope that you submit a CFP for KubeCon. And if not, also we can dig into these other topics in a part 2 session in the coming months. So Steve, thanks a lot for your time today. Much appreciated.
Yeah, thank you. By the way, whoever the artist is, that's amazing. That's just nice work.
Good. I'm glad we'll send it over soon so you'll have it for yourself as well.